Good afternoon, Chase. Here's Nakul from Team Tech Server. Can anyone guess which is the deadliest animal in the world? Some of you might be thinking crocodiles or tiger. But no, guess what? It's a mosquito. It might seem impossible that something so minuscule can kill so many people. But that's true. 700 million people suffer from vector-borne diseases, and there are 1 million deaths each year all around the world. So the problem in the current healthcare system are outdated mosquito surveillance program, insufficient area-wise data available for research analytics, non-existing collaboration between the data science community and the government bodies, no medium to spread awareness. To solve this problem, we have designed a system. So I present before you NOsquito, an integrated management system that includes better surveillance technique, source reduction, biological control, real-time data analytics, as well as public education for vector-borne diseases such as dengue, chikungunya, malaria, and brain fever. NOsquito is classified into four main parts. Let's see it one by one. First one is the CO2 weighted honey trap. So here we are using CO2 honey baited FTA filter paper. The idea is to take advantage of the fact that infectious mosquito split out virus in their saliva not only during blood sucking but also during sugar feeding. The Australian researchers Emilia Johnson, who came up with this idea, is also the mentor of our project. Most vector-borne diseases are found in economically backward areas of India, so cost-effective solutions are necessary. The trap costs less than $1 and is reusable for the whole season. All the instructions for setting up the trap are given on our webpage. A volunteer can get the trap from the nearby NIV, that is the National Institute of Virology, and submit it back to them. The NIV will submit the result in the form of PDF file that contains the percentage of virus in that area, mosquito species spreading the virus, setup time for trap, location, and many more parameters. Once the person submits the result document to our web page with data cleaning and pattern recognition, important data will be added to our database. As you can see here, the volunteer initially needs to fill the first three fields, that is the trap height he has set, the area that he has set the trap, and the geolocation. And then he needs to submit the NIV documents that contains the results. Once he submits the document, the result will be added to our database. Moving on to the second part, the IoT-based trap, that is the Internet of Things. So this trap was designed with the help of Arduino, which is a microcontroller. Every mosquito species has a sound frequency within the range of 150 Hz to 250 Hz. The sound the mosquito produces is there from their wings. Every time the mosquito sits on the trap, the camera will turn on and a high resolution image will be captured. Other parameters such as timestamp, sound frequency, and all the same features from the first trap will also be gathered. IoT-based trap is slightly costly as compared to CO2-based trap, but it yields more data. Our recommendation is used this trap by local healthcare authorities in highly dense mosquito areas. The whole code to create the trap is open source by our team on our GitHub repo. On the web page, the user can upload a zip file or an image file from the memory card which is used in the IoT trap. The species detection algorithm that is designed with the help of convolutional neural networks classifies the species image and adds it to our database. As you can see, we have got the here result, that is Culex tritanosaurus, which is a mosquito that spreads malaria. Moving on to the third part, that is the dashboard. Once the data is gathered with the help of above traps, data analytics can be done. In the current healthcare system, local authorities in Pune, that is the municipal corporation, lacks a dedicated surveillance system. In our system, we have given the decision makers the following option. First one is the map view of each trap set. Once the trap is set and data is submitted to the database, you can see the contents of the trap on the map. Heat map is also been added to see the density of mosquito population in a particular area. The second graph is related to how much trap have been set in a particular city. We expect it to increase exponentially once our project is launched. The first pie chart provides the virus present in a particular city gathered from the traps, while the second pie chart also provides the virus but you can select a particular area. Based on that, the result will be displayed. Studies have proven that trap height for catching particular mosquito species changed based on environmental factor, the ratio of green space, density of housing, etc. Mosquito species are also developing resistance to a dwindling number of chemical insecticides. For this purpose, ML models were designed to get the exact trap height and effective chemicals based on the area for a particular mosquito species. Random forest was used to generate the trap height based on various features, while SVM, that is the support vector machine, was used for effective pesticide classification for a particular mosquito species. We have displayed our result on the web page. Moving on to the next part, that is gathered and submit the data. As I've mentioned in the beginning, there is a non-existing collaboration between the data science community and the research community. So we have added two features. Firstly, anyone can download the data in the form of CSV file. As you can see, you need to select a city and need to select an area, and you can get the CSV file. And secondly, you can submit the insight with some supporting documents. If the insight submitted adds value to our project, it will be displayed on the dashboard section. So in this way, the data science community can collaborate with the research community by giving their valuable insights based on the data. So to get a short overview of NOsquito, it initially gathers data from the trap stored in Firestore database. As you can see in the Firestore database, we have four different collections based on traps. First one is the CO2 baited trap. In the trap, we have different fields of the trap. That is the location, area, the virus, that is the percent of virus that was based on that trap, and many other features. We also provide a dashboard for healthcare authorities so they can take a data-driven decision related to pest management. And at last, we also provide data analytics all around the world to work on fresh data and submit their valuable insights. We are currently in collaboration with domain experts from the field of virology, epidemiology, and bioinformatics from National Institute of Virology, Pune. We continue to rapidly expand our operation by building partnerships with local government and communities around the city. Our vision is of a world where everyone can live in a healthy life, free from the fear and suffering caused by mosquito-borne diseases like dengue, Zika, chikungunya, and yellow fever. Our aim is to eradicate vector-borne diseases from India, but our aim in the near future is to gather and work on as much data as possible for better health-related decision-making. As W. Edwards rightly said, without data, you are just another person with an opinion. Thank you.